All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 40 is on the screen. Let's get started, please. It's still a review of what we've been covering so far. And today's going to be packed with concepts and skills. We need to get started with our graphing and such. Oh, yes, today's the day. And once you're done with the warm-up, make your way over there to get 2 graphing papers. You're going to need them. And also you need to get a Cornell note ready for the session with a Frere model. Oh yeah, graphing is here. So copy that and go. I'll give you 5 minutes. All right, here we go. For the sake of time, warm-up number 40. Check with your neighbors, see what they got for number 1, so I can call on someone what they get for number 1. Number 1. All right, number 1. Help me out, please. Jessica, what'd you get? Solution set of x such that -4 is less than or equal to x 5. Hands if you got that. Looks about right. Number 2, pass someone. X equals to what? Anaya. Not here. Christina, what'd you get for number 2? X equals what? Okay, help her out, please. Diego. Rosas. You got stuck? Okay. Jaden, what'd you get? What? Come on, people. So, common denominator, Jaden. 6, distribute. 12x over 3 plus 6 over 6 plus 6 over 6 equals -12 over 3. Therefore, this is 4x plus x plus 1 minus 4. This is 5x plus 1 equals -4, minus 1 minus 1, 5x equals -5, divide by 5, x equals -1. Hands if you got that by yourself. Okay, good. Thanks. Brooke, are you here? No, she's not here. No. Thank you. All right, let's go to number 3. I'm just going to show the work for one of them. By now you should know how to evaluate using that function. Here it goes. So we got f of equals 3 times -2. The first value I'm going to use is -2. And it reads, f of -2 equals 3 times -2 is -6 minus 2. So f of -2 equals -8. Okay? And my table should look like this. X, -2, -1, 0, 1, 2. And f of x, we should have gotten -8, -5, -2, 1, and 4. All right? And then our graphs, this is our x, thank you. This is our f of x. And our graph should have been somewhere like that, and it's going through the -2 of y. Double check that. All right? All right, set that aside. Let's go to the agenda for today. Agenda for today, we got warm-up number 40 done. And we're moving on, guys. Let's go. Let's go. 2 variable equations. Oh, yeah, we got this. So the word for the school year is, here it goes, graphing. There it is. There it is. Look at that stack of graph people over there. You guys see it? Let's go. That's the only one I'm going to make. The rest you have your notebooks and paper that you got, right, at the beginning of the school year? All right, good. Part of your materials, yeah. Yeah, because that's going to run out pretty quick. Just FYI, BTW. Yeah. The what? Oh, I don't know, Target, Walmart, Keys Bargain. Oh, but they're closed right now. I think I've seen them also at 99-cent store, Dollar Tree. Yeah. What's that? I've seen it at the 99, yeah. Which now I don't know why they call it 99 if it's not 99, right? Everything's like $3-4. I'm like, what? 99. There's stuff like for $5 and $10 or something like that. Yeah. And then the Dollar Tree, it's no longer $1. It's $1.25. You should call it $1.25 tree. Anyways, no Nearpod code. Your home play from last time was to act like tomatoes. Everybody did pretty good on that, yeah? Yeah, all right. Tonight is only 10 problems. So it's in Canvas. I gave you a new module. Just go in there. It's in there. But yeah, it's a lot of your favorite words, slope and graphing. Let's go. Let's go. Get a Cornell note ready, please. Our objective for today, I can define and graph two variable equations. I can define and graph two variable equations. And some of you are already having flashbacks to the graphing portion, right? Now, I get it, guys. I get it. I mean, like I said, for some of us don't do quite well with mathematics. I get it. I experienced that, yes. Did I tell you already, like, what was my challenging course when I was going to school? I already told you, right? Language arts and writing and all of that stuff. So yesterday, we're at a teacher training. Guess what they had us do? Writing. Oh, my goodness. They're like, oh, can you write a reflection? So I wrote a reflection. Okay. Then we did stuff. Oh, can you guys write this? So by the third one, I was like, really? Wow. Too much writing. That's why I became a math teacher, Less writing, yeah, more graphing. Let's go. Woo! I can define and graph two variable equations. So this is a soft intro to functions. And like I said, it's a two variable equation. This is stuff that you should know. I'm going to go a little bit deeper on certain things just so that I can clarify certain things that you struggled with in the past. Hopefully this clarifies it pretty good, okay? So with that said, in your Freyer model, yes? What are you going to write in the middle? Two variable equations. That's our main concept. Two variable equations, what are they? Definition. Two expressions equal to each other and contain two unknown variables. Two expressions equal to each other that contain two unknown variables. Examples. 3x plus 6 equals 3y, 12x equals 4y minus 8, 2a plus 2b equals 14, negative 3n equals m minus 6, and y equals x squared minus 9. Copy that? According to the definition, it says two expressions equal to each other that contain two unknown variables. Now, by now, those terms should sound familiar because I've been using them all year. So let's see. On the left side for this equation, do we have 3x plus 6? Is this an expression? Yes. Is 3y an expression? Yes. Are they equal to each other? Yes. Are there two different types of variables? Yes. Okay, let me go to this one. 2a plus 2b is an expression. 14 is a numerical expression. If we put them equal to each other, it's a what? Two variable equation because it's two types of variables. Same thing here, here, and here. Pretty straightforward, yes? All right, 9 examples. Look at these. Before you copy them, tell your neighbor why each of these three is not a two-variable equation. Share with your neighbor, please. Why are these not two-variable equations? Why are they not? All right, let me start off with Ivan. The first one, why is the first one not a two-variable equation? Doesn't have the equal sign, obviously, and it also doesn't have a second variable. Yes. So, if it's not an equation, tell your neighbor what we call this one without any equal sign. What do we call that? Expression. Anything that is not an equation or an inequality, it's an expression. Yes. All right. Let's go to this one. Valente. This second one, why is this one not a two-variable equation? It has a y, but look at these. Any is the second variable, that is correct. So, bonus question. Let's pass it to Alfredo. What would this one be called if it's not a two-variable equation? Ivan, help him out. It's an equation, but what kind? Frida? Close. How about a one-variable equation? Because it's missing the other one, right? Okay. And the last one. Why is this one not a two-variable equation? Jaden. So what does it have instead? Inequality. Okay. Symbol, yeah. So what would we call this? Bonus question, Jaden. What kind of inequality? It was an inequality. However, Dylan, help him out. Jalen? Two-variable inequality. That is correct. So what makes a two-variable equation a two-variable equation? It needs to have what? Equal sign and two unknown variables. Yes? Man, there's too many flies in here. Bah! My goodness. Is it coming back? Yes? Two-variable equations? Yes? All right. So, we're going to start focusing with the graphing portion only on one form of the equation. Let me show you a roadmap as to where we're going. Look up. Forms of linear equations. There's three types that we're going to be addressing. There's slope-intercept form, standard form, and point-slope form. Look at slope-intercept form. Right utensil down, look up to the screen. Let's see if this rings a bell. Slope-intercept form. Slope-intercept form is very particular because that one is used most of the time to graph linear equations. And me, I like to use colors, like I said. I use green for slope and red for the intercept. But not only any type of intercept is known as a Y-intercept. What does that mean, Mr. Q? That means that if I was to graph a line, here's my coordinate plane. And we know that this is X, this is Y. I'll elaborate more on that. And I was to graph a blue line. As soon as the blue line, this one, crossed the Y-axis, this part right here, as soon as it crossed or it intercept, that's known as the what? The Y-intercept. That's where the line intercepts. All right, what does that equation look like? Y equals mx plus b. Does that sound familiar? Yes. M stands for what? Slope. And the b stands for the what? Y-intercept. Now pay attention to this part. Look up, please. Now, why is this so important? I use colors because it's easier to transfer information. So watch. If I was to give you the equation y equals 3x plus 2. By looking at it, now you can tell your neighbor the slope of that equation. Tell your neighbor the slope of that equation, please. What is the slope? Everyone. Yeah, the 3 is the slope because it's next to the x. Therefore, tell your neighbor the Y-intercept. What is the Y-intercept? Yeah, positive 2. The positive 2 is the Y-intercept. That means that whatever line I graph, it's going to cross through what number of the Y-axis? Positive 2. Copy that really quick. I'll give you some time. All right, so if you notice, who notices that we've been using these on the warm-up? Yes? You're like, oh, snap. Yeah, like I said, I was trying to get you closer and closer as we did the practice before we got to today. And here we are. So which one are we going to use the most? Slope-intercept form. Okay. The second form, which is standard form, we will get to that one, looks like this. Write this down. Standard form, ax plus by equals c. What's so particular about this one? Well, for this one is that the x and the y are on the same side of the equation. Same side of the equation. We will use these because we're going to get into some of the solving quadratic functions and such that we require to see the standard form of it. Now, if I was to give you a linear in standard form that looks like this, 2x plus 4y equals 12, and I ask you for the value of b, you would tell your neighbor what the value of b is. What is the value of b, please? Everyone? 4, yeah. And that's how we can tell when you have both x and y on the same side, you can actually get all these values down. So that's another form. The third and final form that we're going to be addressing is point slope form that looks like this. Y minus y sub 1 equals m times x minus x sub 1. You're like, oh snap, that looks kind of complex, Mr. Q. This is called point slope form. What is familiar from this one? The word what? Slope is familiar, yes? So look at the form. Tell your neighbor which one is the slope in there, please. Which is the slope? M is correct. Yeah, the value of m. We already set that over here, yes? That's a slope. What else? Well, for this kind of form, they have to give us a point. A point. Point being, usually they give us one that has an x and a y value. So, it goes like this. They're going to say, oh, and by the way, since it's only 1 point, I'm going to label that 1 and 1. So it goes like this. They usually say, use the slope of 1/2 and use the point of 5/7 to write an equation. So where would I write 1/2? Right there. Where would I write the 5? At the x sub 1. And where would I write the 7? At the what? At the y sub 1. And then just rewrite it, and there you go. Like I said, we'll get to those later. Which one are we going to focus on for right now? Slope-intercept form. Okay? Good intro, yes? All right. So let me take you back in time. Ready? So it's the late 1500s, early 1600s, and there was a mathematician, philosopher, and his name was, you probably heard this before, here it goes again, René. He's a French mathematician, Descartes. René Descartes. And you're like, that doesn't sound like the last name. Yeah, well, it's French. That's how they pronounce it. However, he contributed to mathematics to your favorite subject, which is graphing. Let's go. And you've heard this before, because now the coordinate plane no longer was called coordinate plane. It was called Cartesian plane. Cartesian plane. And it comes from his last name. Like if I was to discover something, it will probably be called the Q-Bam something, right? You know what I'm saying? So I would use my name somehow in there. Anyways, well, he was sitting down one day, and of course, you know, what do we do on our free time? Math, right? And he was like, okay, so I've been working with these plotting numbers here, but what if I wanted to plot a point up here and not on the line? Well, I need to figure out how to plot something, giving myself directions for that. He said, what if I take this line and I do another line and I just turn it? Oh, snap. So he said, so the original, I've been using just a variable unknown, and I always label it x, which means on my coordinate, my first value will always be x. What would I call the second one? You know, what's after x? Oh, y. That's why the second value of the points is known as y. Now, he rotated that way, which means that all these values are up here. That means that all these values are positive. That means that all these values are what? Negative. And that's how we get the coordinate plane. All right. So, with that said, quick intro to slope. Ready? Here goes the slope. Now, slope, some of you have been covering that since you were in elementary, middle school, but sometimes you just memorize stuff. So here we go. There's a parent that came in the other day. They registered their child here, new student, and I bumped into them and I said, hi, Mr. Quintanilla, how you doing? Good. I need to register my daughter at Frank Wright. Do you know where that's at? Oh, yeah. Let me show you my phone. Boom. I said, we're down here at the high school. You guys see it? Yeah? So you need to go all the way over here to Frank Wright. And by the way, we have a new Starbucks and McDonald's over there. Oh, yeah, I saw it on the way in. Okay. Just get in your car and drive through these homes, and you'll get there faster. No, this is not your video games that you guys play. I didn't give those directions. What kind of directions would I have given? Well, I said, get in your vehicle, go through this parking lot, but let me show you how these are streets. You guys see these streets? Yes. So here's the first one. You're going to go up 1, 2, 3, 4, 5, 6, 7, up. Then you're going to make a right turn and go what? 1, 2, 3, 4 to the right. Those two values is what we call the slope, which is rise because we go up, and then we make a right turn and we go run to the right. It's not the line, it's the change in y and change in x. Is it coming back for some of you? Yes? So that's why we call it the what? The rise over the run. You guys remember that? Yes? So once again, slope is also known as rise over run, or also known as slope. We're going to be working with that today. Okay? So steps to do. Don't copy this. Look up. You should already know how to do this. We're going to go straight to the graphic portion right now. But here's what we're going to do. We're going to take 2 points. We're going to plot them. We're going to compute the change for y and the change for x. And then at the end, we're going to simplify. All right? Let's put this to work. Here we go. Get your big graph paper in front of you. Everybody should have gotten one from over there. Yes? Okay, good. Big graph paper. On the top left, I want you to write example Q and write these two coordinates, -4, -1, 4, and 3. -4, -1, 4, and 3. We're in the biggest graph paper that you have. Yes? All right. -4, -1, 4, and 3. All right. So let's plot this. Let's see if we remember. Look at the first point, -4, -1. Which one's the x? -4, yes. And then the other one should be the y. So let's start at -4. -4 of x is over here. -1 of y is down 1. So that's my first point right there. Next, let's go to the second one. Our x is 4. Our y is 3. So let's go to 4 of x, 3 of y, which is up here. There it is. And then you sketch your line, connect those two like so, nice and straight. All right. So now that we did that, let's write m for slope, which is what? Rise over run. Rise over run. For the rise, I want you to put an arrow going upward or downward. Rise is always either up or down. The run is always to the right. For right now, we're always going to go to the right. Okay. So here we go. We're right here. Hey, wait a minute. Does this look like the directions I gave on Google? Let's go. So we're right here, and we need to get to here, which means what? Do I go straight through the houses here? No. I go how many steps up? 1, 2, 3, 4 steps up. So my rise is 4. Then I make a right turn, and I go 1, 2, 3, 4, 5, 6, 7, 8. And the last step, simplify to lowest terms. So this is what? 1/2. So my slope for this line is 1/2. Now, some of you are like, Mr. Q, so if we got from one point to the other using 4/8, what does 1/2 mean? It means that if you go one step up, 2 to the right, we always land on the line. Starting from here. Here it goes. Look up. 1 up, 2 to the right. Do I land on the line? Yes. Let me do it again. 1 up, 2 to the right. Do I land on the line? Yes. And again. And again. Let's go. All right, on that same one, underneath where you wrote example Q, write example super Q on that same graph. And I want you to do this one by yourself. Plot the points and find me the slope, please. Bless you. All right, here we go. Let's see. I'm going to go with my first point. This is the value of x. This is the value of y. So I'm going to start at x -2. This is my x-axis. -2 is right here. Then it says 6 positive of y. So I'm going to go to 6 positive of y, which is up here. There's my point. And if you got that, okay, let's go to the second one. This is our x. This is our y. So I'm going to start at x2. x2 is right here. And then y3, I go up 3 to right there, plot my other point. There it is. And then just connect those from left to right. Remember, we always read it from left to right. Now, check this out. If we read it from left to right, which is my first point? This one? No, this one, because I'm going from left to right. Left to right. So if this is my first point and I need to get to this one, do I go up? No, I'm going which direction? Down. How many steps? 1, 2, 3. And that is a -3 because we're going what? Down. -3. So down is negative, up is positive. Okay. Make a turn and then 1, 2, 3, 4. So that is -3/4. Hands if you got that by yourself. Okay. Good intro, yes? You're like, yes. All right, when the pass comes back. All right, don't copy this next one. Look up. Now instead of giving us 2 coordinates, they give us a line. But we can still find the slope. Is that correct? Because we need what? 2 points. Picture your 2 points on that line. Then count the rise to the run. All right, give me 1 point, Alessandra. Which point did you start with? 0, -2, right here. Okay. Give me another point. Caleb. 2. 2. not on the red line. So remember, it has to be on the red line in order for us to find the slope. So it would be what? 0, positive 1. Yes? All right. Did everybody picture those two? Yes? So what would be our slope, everyone? How many steps up? 1. How many to the right? 2. So it's 1 over 2. But what if I chose a different point than Caleb, and I moved this all the way over here? Is it still on that line? Yes, it's right at the edge, Mr. Q. All right. So count the steps for the rise and the run. What's the rise, guys? 1, 2, 3. What's the run? 1, 2, 3, 4, 5, 6. Can we simplify this? And it becomes what? Why? Because the slope will always have us fall on the line. Just pick 2 points. Doesn't matter which 2 points. All right. We good? Yeah? Same thing with that one. All right. Copy this one on your Cornell notes, please. Cornell notes. Write that down. Hurry up, hurry up, hurry up. We don't label it with numbers right now, just like that. So, this is our x-axis. This is our y-axis, the one that goes up and down, yes? And I'm going to plot 2 points. Here's the first one. Plot that point right there. And I'm going to plot another one over here. Connect the 2. There it is. And we're going to find the slope. Rise over run. Okay? And we're like, how do we do that, Mr. Hughes? You haven't given us any numbers. Oh, okay. So I'm going to picture that this is 2 of x and this is 8 of x. Okay? That means about right there, okay? And over here for the y, let's say this is 4, and this is about 7, okay? All right, so Valenta's going to help us out with this one. So I want to go from here to here. That means I need to take steps up. Is that correct? All right. So before I ask Valenta, tell your neighbor what y value am I starting from here? Where am I at so far? Where am I at so far? All right. And I need to get to here. Is that correct? So how many steps, Valente, to go from here to here? 3. That is correct. Hands if you agree with 3? Yeah, that is correct. 3. So my rise is 3, okay? All right, and then I make a turn right here, and then I need to go from here to here, from here to here. So, how many steps do I take from here to here, Valente? I went up like this, right? But I'm still here on this level. I'm going from here to here. Tell your neighbor, guys, while Valente looks at it, how many steps from here to here? Valente? 6. Hands if you agree with that? Yeah, 6. So my slope is 3 over 6. So far so good, yeah? My goodness. And of course I can simplify, and that gives me 1 over 2. Okay. So, check this out. But what if I said, Valente, I don't want you to count steps. I want you to look at these 2 numbers and do something with them to get that number. Tell your neighbor, guys, what Valente needs to do to those 2 numbers to get that number. Yeah? Valente, go. Yes, well, so what, tell me what to write. Well, what you just said. No, no, no. You said to subtract, right? So what do I write? 7. Yes, and that gives us 3. All right, with that same idea, look at these. What do I do with these numbers to get that, Valente? Tell me what to write. Well, Valente, let's go. All right. So far, so good. But let's give Valente a challenge. That was too easy, right? And now I'm going to label this one. This is 0.1. And I'm not going to use numbers. How about that? Ready, Valente? All right, so watch. Instead of giving you numbers, this is the first point, and it has an x value and a y value. This is the second point. It also has an x value and a y value. But since this one's the first point, we're going to label this one x sub 1, y sub 1, which means this is the second point, which is labeled what? X sub 2, y sub 2. So, Valente, look up. You said earlier that with numbers, you subtracted 7 minus 4 to give us 3. But now I don't have any numbers. What would I write for the rise? Talk it over to your neighbor while Valente thinks about it. What do I write for the rise? All right, Valente, go. What do I write? Y sub 2 minus y sub 1. Hands if you agree with that. Which means on the run, what would I write? Yeah. Write that down, guys. This is the formula for the slope. Slope formula. Let's go. Let's go. And that's where it comes from. We get it from looking at 2 points on the coordinate plane, just with values of x sub 1, x sub 2, y sub 1, y sub 2. So for tonight, you're going to have 7 problems of finding the slope using this formula. So, which get us started with example number 3Q. Copy that, please. And it reads, find the slope of the line that contains 2, 5, and 8, 1 on your Cornell notes. Hurry up, hurry up, hurry up. 2, 5, and 8, 1. If you want to just write the 2 coordinates, that's okay. Here it goes. Going to go pretty quick. Find the slope without graphing. So step 1, if I read it from left to right, which is my first point? This one, yes? So I'm going to label this one x sub 1, y sub 1, which means this is my second point, and I'm going to label it x sub 2, y sub 2. Now that I have that, let's write our formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Put the minuses first. I'm going to use blue for the second point, so I can start with the second point. What is y sub 2? Y sub 2, everyone. 1. Is that correct? What is x sub 2? X sub 2 is 8, which goes right there. Let's go to the next one. What is y sub 1? Y sub 1 is 5. And x sub 1 is 2. Here we go. What is 1 minus 5? That's negative 4. What is 8 minus 2 is 6. Simplified, this is negative 2 thirds. From 1 to 5, I'm comfortable with these? Yes? Let's do another one. Copy this one. Example 3 super cube. Negative 2, 7, negative 2. Negative 2, 7, negative 2. I gave you this one with a lot of negatives so that you can see one of the possible mistakes you might be making and anticipate them. So what is the first thing we do? We label it, right? So what would I label this, Valente? x1 y1. That means this is what? x2 y2. Yeah, x1 y1 x2 y2. Formula: y sub 2 minus y sub 1 over x sub 2 minus x sub 1, blank, minus, and minus. Make sure you put those minuses first, or else you're going to make a mistake. Here we go. What is y sub 2? Y sub 2 is negative 2. What is x sub 2? X sub 2 is 7. Let's continue. Y sub 1. What is y sub 1, guys? Negative 2. And x sub 1? X sub 1 is negative 2. All right, let's do this. You're like, wait a minute. What is negative times a negative? Positive, and this is a positive. So this becomes 0 over 9, which is 0. All right, from 1 to 5, I'll come through you with these. 5, 5, 5, 4. Is it coming back? Yes. Like I said, this is like 6th, 7th grade stuff. Yes? All right. And so on and so forth. Copy this one, example 4. So for home plate, the ones we just did, you're going to have 7 of those. And then you're going to have 2 of these. Example 4. It says, find the slope given 4x minus 2y equals 16. Does this look familiar, by the way? Yes, it does. It looks like the warm-ups, doesn't it? So what is your noodle wanting to do? What would you do with that if you didn't have any words there? Solve for y. Haven't we been practicing that on the warm-ups? Yes, let's solve for y, which means minus 4x minus 4x, negative 2y equals negative 4x plus 16. Divide by negative 2, divide by negative 2. Y equals 2x minus 8. By looking at that, I can write my slope-intercept form, which is mx plus b. So tell your neighbor the slope of that equation. Everyone? 2. That is correct. The 2 in fraction form is 2 over 1. You're going to have 2 of these. And last but not least, here we go. Copy this one on the medium side graph paper. Turn the graph paper over. I want you to write on the side slope, negative 2/5, intercept 4. Slope, negative 2/5, intercept 4. Here we go. We're going to graph this, but we need to write an equation first. So what is our form that we've been, that I said we're going to be using? Y equals mx plus b. So where would I write the slope, everyone? Instead of what? Instead of the m, yes. So I would write negative 2/5 because this is our slope. What would I write at the end, everyone? Plus 4 instead of the b, yes, because that's my y-intercept. So we got 20 seconds. Here we go. Let's graph this. I'm going to start with positive 4 of y. Plot your point on 4 of y. There you go. Hold on. Let's finish. And then I'm going to plot 2 more points using the slope. How many steps down? 2. How many to the right? 5. So I'm going to go 1, 2, 1, 2, 3, 4, 5. I'm going to do it again. 1, 2, 1, 2, 3, 4, 5. And that's how we graph a line using slope-intercept form. You got one of these for home plate. Have a good one, guys. Enjoy your home plate. You can find it on Canvas in Intro to Functions. Let's go. Let's go. Have a good one, guys. See you guys tomorrow.